So, welcome to lecture number 50. We are dive deep into sorting and searching algorithm in C++. In the previous lecture, we discussed the theory of this algorithm, and now we are exploring both the theory and practical implementation step by step. So, by the end of this lecture, you will understand sorting algorithm and searching algorithm. So, I will just brief introduce what is meant by sorting algorithm and searching algorithm. So, in sorting algorithm, we include bubble sort, selection sort, insertion sort, quick sort, merge sort, counting, and the last one is Radix sort. So we all these all we learn in this lecture. And the next one is searching algorithm. It is searching algorithm. In this, it's have only two, that is linear search, and next one is a binary search. Okay. So additionally, we will cover real world example for each algorithm to make them relatable and easier to understand. So okay, so without wasting our time, let's get started. So the first one is in sorting algorithm, the first one is bubble sort. So I write this here, that is sorting algorithm. The first one is bubble sort. Okay. So bubble sort repeatedly compare adjacent element in the array and swap them if they are in the wrong order. That is bubble sort repeatedly compare adjacent element in the array and swap them if they are in the wrong order. Okay, this process is repeated until the array is sorted. It's simple but not enough for large datasets, so bubble sort is only for a small dataset. So the real world example of this is like, think of arranging people in a queue by height. You compare adjacent people and swap them until everyone is in the correct order, right? So we are taking an example of people comparing their heights. Okay, so I hope you got this, like what I am telling to you. So without wasting our time, let's get started our editor. So our today lecture is too lengthy, so you can fast forward this. Then after that, once I write all this, I will explain you the code as well. Okay, and I will give you the link of my repo in the description. So I write it. So I write the code. Then I will explain it to you. You can fast forward this. Okay. So So yeah, this is the code of our first, that is bubble sort. So let's run without any error. So yeah, this is the output, that is 11, 12, 22, 25, 34, 64 and 90. So the outer loop ensure the process run for all the elements. Okay, and the inner loop compare adjacent element and swap them. That is, this one is the outer and this one is the inner loop. And the bubble sort has a worst case time complexity of O not n square. That is, just a second, worst case time complexity of O not n square. Okay, so this is the complexity of bubble sort. So the next one is selection sort. That is selection sort. So selection sort select the smallest element from the unsorted portion of the array. That is selection sort select the element from the unsorted portion of the array and place it at the beginning. That is, these reduce the number of swap compared to bubble sort. So that is note, reduce the number of swap compared to bubble sort. Okay, so let's take a real world example for these as well. So imagine arranging book by size, like arranging books by size. Okay, you find the smallest book and place it first, then repeat for the remaining books. Okay, I hope you get the example, like real world example. So again, we are going to editor. I will write the code, then I will explain to you. You can fast forward because our today lecture is too lengthy. Okay. So let's get started. So I will remove this, and we did not want this line as well. So yeah, let's start. You can fast forward this as well. So this is the code of a selection sort. So let's run the code. I hope we did not get any type of error. And yeah, this is the sorted array. So just a second, I will make it a little bit attractive. So let's run again. So yeah, this is the result. Is the output is 1 2 3 4 5. Okay, so the algorithm select the smallest element in each iteration. Okay, so the first one is 1 and place it at the start of the unsorted portion. Okay, and for selection sort also has a time complexity of O not n square but reduce swap. That is, I write it in our editor as well. That is time complexity is same, that is O not n square but reduce swap as compared to bubble sort. So the next one, that is third one, is a insertion sort. Insertion sort. So insertion sort build a sorted array incrementally. It picks element one by one and insert them in a correct position in the sorted portion. That is, insertion sort build a sorted array incrementally, and it picks element one by one and insert them in the correct position in the sorted portion. portion. Okay, so the real world example of this is the sorting playing cards in your hand. You take one card at a time and place it in a correct position, right? So that is sorting playing cards. Okay, you take it one and then place it in the correct position. So again we are going to our editor. You can fast forward the video and then I will explain it to you the code. So we'll again remove it. So these are the same. So yeah, in this again we have to write for. So yeah, this is the code of insertion sort. So let's run the code and we get the value that is 11, 12, 22, 25, 34 and 64 and 90. Okay, so in this the outer loop pick the key element in insertion, that is this one. Okay, and then the inner loop shift larger element to make space for the key. Okay, and then the last one, that is the time complexity for this is also same, that is O naught n square in the worst case, but efficient for nearly sorted array. That is, I am writing this as well, that is I am writing it in a short, that is time complexity is also O naught n square for worst case. Okay, the fourth one is quick sort, that is quick sort. So quick sort is a divide and conquer algorithm. That is, quick sort is a divide and conquer algorithm. That is, it select a pivot element and partition the array around it. That is, sort the two partition recursively. That is, sort the two partitions recursively. Okay, so the real world example for this is like sorting file by size. That is, sorting file by size. Okay, so you pick one file as a reference, separate smaller and larger file and sort them. Okay, I hope you understand this one as well. So again, we are moving to our editor. I'll write code again. So yeah, remove this all. First integer, it's integer. Partition, integer array, and then integer low, and then high, and then in this we again write integer pivot high, again integer I equals to low minus 1. That is I equals to low minus 1. Okay, and then we apply for loop for j, and in this we take again if condition for this. If array j less than or equals to pivot, in this we take I plus plus. Okay, and then we swap it, like swap array I and array j. Okay, and then again we have to take swap array I plus 1 now and high, and then we have to return the value I plus 1. Okay, then we take a next function, that is void, that is quick sort. Again we are taking integer low high, and in this we have to write again if low is less than high, we have to write integer pi participation array low and high there. Okay, and then again we have to take quick sort, and again we are taking, for right now we are taking pi minus 1, and again we are taking pi plus 1. Then this is one, and then for right integer main we have to write again array of, let's take a 10 7 8 9 like that. Okay, then we have to write integer of n, that is size, like size of array upon size of array, that indexes. Okay, and then we have to take quick sort for array, that is n minus 1, and then we have to print array sorted array, that is cout sorted array, and then we have to apply condition for integer I equals to 0 and I less than n. Then we have to take I plus plus, and we will print array of I. So this is the code, and then the last our line, that is return 0. So I hope we did not get any type of error in this. So let's run the code and we get the error, that is, just a second. So what happened in this? Let's run again. Just a second. Let's run. Yeah, run repeat. we get the error in this. I'm not sure what error we get, so we just correct it out and take it here, and let's run again. So yeah, we just copy this and make it in the C++ compiler. I will correct it. Okay, so I hope we did not get any type of error in this. So we are taking the previous code, copy it, and let's run the code. So the error is undefined reference of integer main. Oh, just a second. It's main. That is main. So run the code. Yeah, our replit is correct. So we are writing it in a wrong way. So let's run. That is sorted array 1, 5, 7, 8, 9, and 10. So partitioning divide the array into smaller and larger element based on the pivot. Okay, and then recursive call sort the left and right partition. And again, the time complexity for this, like we say quick sort, it's o not n log n. That is, just a second, time complexity for this as well, o not n log n is the average case. This is for average case. Okay, so the fifth one is merge sort. That is, just a second, merge sort. Okay, merge sort is another dive and conquer algorithm. That is another dive, divide and fear algorithm. It's divide the array into two halves, recursively sort each half, and then merge them into single sorted array. That is, divide the array into two halves and then sort each half and then merge merge it into one array, one sorted array. Okay, so the real world example for this is, let's take an example. Imagine two librarians sorted book. Like, each librarian organize half of the books and then they combine their sorted stack. Like, we are taking an example of librarian sorted half of books collection. Okay, and then merge it into one library, one library set, or we can say book of collection. So for this is the lengthy code for this, so I will suggest you to fast forward this and then we are explain you this as well. So let's remove this code and move further for this. So first we take a void. This is temporary arrays for left and right halves. Okay, and then we apply for condition, and then for L, that is capital L I, this again we apply for condition for right, and then again it's for right, and then we apply integer I equals to 0, j equals to 0 and k equals to left. That is its merging process. Okay, and then we apply while condition, and in this we are taking a bracket, just a second. So in this we apply if condition. If left I less than or equals to I, right I, then array k is equals to then we take I plus plus for this. Okay, then we apply else condition. Else we are again taking array k equals to right j, then again we have to take j plus plus for this, and then this happen, then we take k plus plus for this, and then simple. Okay, and then we again apply while condition for I less than n1, and this happen, then we again array k is equals to left, then we have to take again I plus plus and again and k plus plus, that is I plus plus and k plus plus in the simultaneously. Then we again apply while condition for j and 2. So write it same for just replace with a L, capital L to R for right condition, and then again j plus plus and k plus plus and k plus plus. Okay, so then we have to write the void function in this. So then after this void merge sort and integer array, again we have to take left right all that, and then we apply if condition. If left is less than right, then we have to take integer mid divided by 2, right minus left divided by 2. Okay, and then after this we merge, that is array left and mid, and then again we merge left mid and right. Okay, that is mid plus 1 and right, and last one, just a second, for right, and then we apply left. Then this is the code, and then we write integer main function. So in this we have to again take a array of like size whatever you want to take, then again we have to calculate the size using index formula, and then we have to merge, and then the last one is we have to apply for condition, and in this we write again sorted array, and the last one, that is the return 0. And we missed out something, that is after this we have to write cout or like what sorted array, that is sorted array, and lastly. So I hope we did not get any type of error, so let's run the code. Yeah, so again the array is sorted in 1 2 3 5 8 9. So in this the array is repeatedly divided into two halves until each half contain only one element, and then the merging process, that is this one, okay, combine two sorted halves into a single sorted array, and for merging sort has a time complexity of O naught n log n. This is make it efficient for large data set, that is for this as well the time complexity is n, say O naught n log n, and make it just a second, efficient for large data sets. Okay, the next one is counting sort, that is counting sort. It means that is counting sort is nothing but it is a non-comparison based sorting algorithm. In short, we write non-comparison based sorting algorithm. That is, it's work by counting the occurrence of each element and then placing them in the correct position. Okay, so it's basically comparing and then it's placed in the correct position. So the example for this as well is, imagine sorting balls by color. that is sorting balls by colors. Okay, you count the number of balls of each color and then arrange them, right? So for this we have to write again the code, and then we will explain you the code as well. So just a second. Yeah, so again we have to go into our editor. Let's remove whole code and write it again. That is void counting sort. Just a second. Sort. In this we have taken again integer and integer array and n. So in this we write for max, that is integer max, that is integer max equals to max element array and array plus n. Okay, that is something make it mistake here. That is just a second. Integer max element. So I did not declare, I guess so. Okay, we check it later. Just a second. Then we have to write for minimum as well for integer min. So we again take, so yeah, let's run, and then again we have to take range, that is for maximum minus minimum plus 1. Okay, and then we have to take for count, like what is the count of this. So we are taking count, that is integer count range, and it's we are taking equals to 0. Okay, and then we have to take output, that is integer output n. Then we apply for loop for this, that is for I equals to 0, I less than, then cout array of I minus minimum. Okay, and then we again apply for loop for the another one, that is, and we apply for this for maximum, that is count. Okay, and again we apply for the next one, that is array for minus m, that is count. Okay, and then we again apply for, right now we are applying n minus 1, and now we are taking I equals to 0 for this. So then it's again output, that is array I, that is output of this. Okay, and the last one, that is just a second. Yeah, so after this we take integer min, and in this we write again the that array, that anything you want to take the value of this, and then again you have to counting sort, and then after this we have to write cout, that is sorted array, and then we have to apply for condition for this, and the last one we have to print the array, and then we have to write the value, that is return 0. So I hope we write everything correct. So let's run. We get the error in line number 5, 6 and 8. So we get the error in this, that is in the counting sort. So I will work on it and give you the exact running code in the next video, and then we will start our next video lecture. Okay, so the seventh one is, that is Radix Sort. Okay, that is, it's sort a number digit by digit, that is sort number digit by digit. Okay, that is starting from the least significant digit to the most significant digit, and using a stable sorting algorithm like counting sort as a subroutine, right? So we are taking a real world example for this as well, that is sorting phone number by their digits, first by the last digit, then the second last, and then so on, like sorting phone number. by their digits, like first by the last digit, then the second last, and so on. Okay, so these all are the concept of sort. So the I already write the code because it's take too much time, so I already write the code and let's run. We did not get any type of error, I hope so. So we get the value that is sorted array, and that is 2, 24, 45, 66, 75, 90, 170, 802. Okay, so we recall all these in animation format used in W3 school, that is W3 school uh, array. So let's see plus plus. So where is it? Yeah, no, it's in DSA. Where is it? DSA, DSA, DSA. Just a second. DSA array, W3 school. So yeah. So the first one, that is the normal array, that is, let's check the, we take a speed is normal, that is, let's run, that is 1 2, then at the smallest value is 29, now 28, and then yeah, so the 28 is the lowest value. Okay, so this is for normal array and we increase the speed, so let's check, find the lowest, then he the value find the lowest. The next one is bubble sort. We already covered this like theory part and animation or implementation. The speed is normal, so then sort, like you check it's compared to values and then animate it, like sort the array, that is again check, again arrange the value, again swap it, that is which one is small and which one is greater, again swap, so it's swapping the element, then again swap, so it's already happening because it we are taking a speed is in the just below average, so that's sorry above average, so that's why it's take too much time. For the another sort, that is selection sort, we take a more speed, that is this is the sorting, so you just concentrate on it. This is, if you want to zoom it, I will zoom it on the screen, so just a second. So yeah, okay, so we increase the speed, so let's check. I will again increase it in the this format so you can, so the bubble sort, just check it out. So how the value is, like smallest value is in the starting position going. Okay, then I hope you get the value. Then we are moving to selection sort. Okay, so for this we are again taking increase, just a second. So yeah, this is a selection sort, we increasing the speed, so that okay, so it's check the all one by one value, small value, and then sort like this. So this like, you can refer this in like W3 school DSA, you will get the values like animation as well. So for insertion sort, you again we are come take animation, then insertion sort, so check and swap, check swap, check swap, check swap. Okay, so let's run. We are increasing the speed, so this is what we get. Okay, the next one is quick sort. For this as well, we again increasing the speed and increasing the size value. So quick sort, this is already compare and just swap it within a second. Then counting sort, we get the error in this code, so let's run this animation and I will give you the code in the another lecture. So we increase the speed, so let's run again. Okay, just a second, so we take average speed, so let's run like counting sort, the first, second, third, fourth, fifth, sixth, seventh, same size. Okay, then check it and increasing, then this happen. Okay, one by one, that is same number of values, like how many is same, then it's arranged in the or sequential order. Okay, and the last one is, that is Radix Sort. So for this we are again take, that is, so step, check this one, like it's the last digit that ordering in the ascending order. Let's again and again. Okay, so this is what we get. So new value. So again we are taking like 490 something 136. So we already checked that is 113 is the less number. So let's run. So first compare this one, then the second compare, and the third as well. So compare. So you get like 113 is in the top and 532 is in the above list. Okay, and then last one is the merge sort. So we already covered this, like what is mean by that. So let's merge these as well. So you check this one. Take a partition, again merge, take a partition, again merge, partition, then merge. Okay, for this same as well. So let's increase the speed. Then this is the one partition and this is the second half. Okay, then it's compare and then value. So this is what we are going to learn in this today lecture. So I know this is too much lengthy lecture, but yeah, it's fine for us. So in the next video, we will finalize the searching algorithm. Searching algorithm, that is linear and binary. But before this, we take the counting sort implementation, because we our today code is not running that much, but it's a segregation fault. So I will check it and then we will implement that code as well. Then we are starting with searching algorithm and linear search. So I hope you like the video, and I hope your doubt is also clear. So if you like the video, then like, share, comment, and subscribe to the channel, and stay tuned for the another session, that is lecture number 60. Okay, so bye bye.